Go with an exclamation point. Yay, go. Alright, here's a warm-up problem. I would like you to factor it completely. Factor until you can't factor anymore.
Where's my other binder?
I don't know.
That's something.
Okay, what do we got first? What are we going to factor first?
8.
A 2x? Just a 2x?
2x squared.
2x squared. I like that better. Okay? So if I factor out a 2x squared, what's left over?
4x squared minus 9.
4x squared minus 9.
Equals what that.
Yes?
Yeah.
Okay, are we done?
No.
Why not?
Because you have to factor it out.
What do you mean you gotta, what do I gotta factor out yet?
4x squared minus 9.
Why do I have to factor out 4x squared minus 9?
Perfect squares.
Because what?
They're perfect squares.
4x squared is a perfect square, and 9 is a perfect square. But
Yeah.
even more than that, they're not equal. Why can I factor 4x squared minus 9? Because it's subtraction. More importantly is because it's the difference of perfect squares. If it were the sum of perfect squares, then no, we couldn't factor it any further. We'd leave it at whatever we'd had after this one. Yeah. But this one then factors to be, we've got 2x squared out in front, we've got 2x minus 3, and 2x plus 3.
Okay. Can you give me a second to process that?
Sure, because I'm going to say something more about it too, if that's okay.
Where did 2x squared even come from?
The outside.
Well, obviously the outside. I'm saying, like, where did it come from?
Because 4x squared times 2x squared equals 8x 4.
Wow, right.
What if we switched around the plus and the minus?
That would be fine
Yes?
if you wanted it.
Yes or no?
No.
Can we switch around the plus or the minus? Can we go like this, the red one underneath the box?
I don't think you should. But you could. No, you could. No. Then it'll change the sign.
You sure?
I don't know. Everybody's telling me no, but I shouldn't yet.
In this particular case, it's the exact same thing. Because order doesn't matter in multiplication.
It works.
No, I knew it.
You knew it, but I was able to just with my eyes convince you to
Yeah.
change your answer. First base, did you get it processed now, Ross? Did you get it processed now? Okay, here we go then. So we've got one more way of factoring to go over yet. So far, remember you had a list, you got a list going somewhere in your notes. Number 1 was greatest common factor, which we just did in that warm-up problem. Number 2 was difference of perfect squares, which is actually what we did in that last warm-up problem too. Number 3 was the trinomial type one with the butt cheeks and the 2 sets of parentheses and the guessing and the checking and all that fun stuff. Number 4 was cubics, sum and difference of cubes. Okay? Number 5, so our 5th way of factoring, number 5 is factoring by grouping. Now, factoring by grouping is when you have a larger polynomial, meaning more than 4 terms. Okay? The only kicker with factoring by grouping is that you have to have an even number of terms. So 4 terms is going to be the most common one that you see. So if you automatically see 4 terms, you should think grouping first. Okay? But if you had 6, if you had 8, if you had 10, if you had 28 terms, you could also factor by grouping. Okay? So it's a useful strategery. Okay? So the first thing that you have to do when you're factoring by grouping is you have to make sure that your polynomial is in standard form. Now, I know I'm asking you a lot because I'm going to ask you to remember back a week and a half ago, okay, I know, long time, standard form of a line. I want the standard form of a polynomial, which is in your notes.
That's a good question.
Standard form of what?
Oh.
Nope, that's of a line.
Are we talking about the 83?
No.
The 82 minus.
Nope.
I think there was a wrong note.
Just give us the answer at this point.
No.
Say it louder.
The descending order of exponents.
So the standard form of a polynomial has the biggest exponent first, then the next biggest exponent, then the next biggest exponent, then the next biggest exponent, and it ends with the constant, with just the number. Okay? So that's the first thing that you got to make sure, is that your polynomial is in standard form. The second thing that you're going to do, then, is you're going to cut it in half. Which is why you have to have an even number of terms. Because if you're going to cut it in half, you got to have the same amount of terms on both halves. And then from there, you're going to do 3 greatest common factors. Okay? So the first one, you are going to greatest common factor the left half. The second one, you're going to greatest common factor the right half. And then lastly, you're going to greatest common factor both of those outcomes. So you're almost, I basically say you're just GCFing the whole thing then after you've done the other 2 GCFs. Okay? Let's put it into work. First off, is it in standard form? Yeah. Biggest exponent first, next, ends with a constant.
Now that I see it, I can see what you say.
Okay? Alright. Second thing says we need to cut it in half. Next thing says I need to GCF my left half. Yes, ma'am.
How come you put, does it matter which side of the plus or minus sign?
Well, you wanted to go with the number. You don't just want a plus at the end.
Okay.
With me?
Yeah.
Okay. But no, that's a good question.
Got it.
And you'll see why even more, you'll see why that's even a better question in the next example. Okay? All right? So, GCFing on the blue. 1 x squared.
Yeah.
Okay, so just an x squared. What's left over? X minus 7. Yeah, that's the first of the 3. Second of the 3. Now I got a GCF the right half.
7.
7? 7 doesn't go into 8.
Oh, 8.
So 8? What kind of 8? Positive or negative? Positive 8, okay. So then I would put my plus 8 there. What's left over? X minus 7.
That's what I meant.
Gotcha. I understand. Okay. So we did that. Now I've got to GCF both of them. What do both of those have in them? No. They both have an x minus 7 in them. Okay? So I'm going to factor out an x minus 7. What's left over? X squared plus 8.
I'm just really confused. Like, I see where you're getting it from, but I don't know how you did that.
Okay, so if I wrote this like this, if I said, I'm going black. If I said this was x squared z plus 8z, what would you do to GCF that? You'd factor out a z, right? And you'd be left with what?
Squared plus 8.
X squared plus 8, right? Right? Do you agree with that?
Yeah.
Kenny, you got that?
Because when you distribute it, it becomes the top thing.
Yeah, well, that's why we factored them out.
Right?
Okay? With me? Okay? Now here I'm going to blow your mind. Ready?
They can.
There's your two z's. So you factor out a z, and you're left with x squared plus 8.
I got it.
I'm just confused.
Talk to me. I'm listening.
Yeah.
So, can I factor either one of those two anymore? Can I factor x minus 7 anymore? No. Can I factor x squared plus 8 anymore?
No.
Yes?
Yeah.
Why?
Squared.
Well, hold on, why? Okay, because x squared is a perfect square, but 8 isn't. Okay, so we can't do that. 8's a perfect cube, but x squared isn't. So no, so we're done. So that then is as far as we can factor. That's not very nice.
Sorry, Rod.
Okay?
Sorry, Rod.
All right. You try it.
Okay. That's amazing. Beautiful. Great.
Go for it. And here we go.
I did it.
All right.
But we're not done.
So it's in standard form. We divide it in half. Okay? That was a bad dividing in half, so let's divide it in half because it looks like an I. Okay, there, better divide it in half. Greatest common factor, left side. 9
T squared.
t squared. What's left over?
You got 3t
3t plus 5. Okay, love it. Right side, greatest common factor.
0, 1.
Negative 1. What's left over then?
3t plus 5.
3t plus 5.
But why would you do that if it's just
Ooh.
the same thing?
Why would we do that?
So
Because
different.
now what happens?
Because it needs the whole thing.
Because now we can, when we do the whole thing, now both of them have a 3t plus 5 in them. Yes. Kaboom. So then I gotta factor out a 3t plus 5. What's left over?
9t squared plus minus 1.
Can I go any further?
Yes.
Yes?
No.
What do we got?
I get lost at this point.
Okay. Well, because now we gotta look at these two.
Wait, we're not done?
Well, can we factor this?
No.
No. Can we factor this?
No.
Yes.
Yes.
Because it's a perfect square, right?
3.
Right? And it's a perfect square, right? And it's a minus sign. Yeah. So then this one, so 3t plus 5 is, that one can't be factored, so that one's going to stay. This one becomes 3t minus 1, 3t plus 1.
1 second.
opposites.
Where did it left it as
If we left it one level up,
You'd be wrong.
like here,
yeah.
okay, so when you're going to Mosinee, you stopped in Rothschild and said, hey, hi, Mosinee. Or you're going to Stevens Point, you stopped in Mosinee and you said, hey, let's go to college.
So you get that.
Because it's not factored. It's factored, but it's not factored. Okay. Yes, ma'am.
Can you explain the red part?
Here's my Z again. There's my Z again. So I factor it out. And I'm left over with 9t minus 1. Okay? All right. Enough with that just straight up factoring stuff.
Yeah. Oh.
We still got to factor.
Yeah.
We just got to solve. Alright, so we're going to move on to solving equations. I want to solve the rest of the day today, and I want to solve all day on Wednesday. Well, actually, to be honest with you, the rest of this unit is all about solving equations. So we're going to solve for a while, but solving by factoring, that's going to be today and tomorrow, or today and Wednesday. Okay? I remind you of the fundamental theorem of algebra. The fundamental theorem of algebra says that the degree of a polynomial equation, what's the degree again? The biggest exponent. Yep, okay, so the biggest exponent not only tells me a week and a half ago, it told me the direction that the polynomial graph was going, right? Okay, that was what the degree said. If it was an odd degree, it went in the opposite direction. If it was an even degree, it went in the same direction. Okay? Not only does that tell me that, but it also tells me the total number of solutions, real and complex, that polynomial will give me. So if I go back one slide for 2 seconds, how many solutions should this one give me? 3. Because it's got a degree of 3. So I should get 3 solutions. Now you're saying to yourself, well, what's a solution? It's an answer. It's a 0. It's a root. It's a solution. Those are the 4 different ways that we see it.
Wait, so are we going to be graphing?
No. But we can. Right? For right now, until next week, we're just going to deal with the real ones. Okay? After that, then we'll get into those imaginary. Okay? I'll give you a little bit of it today, but it's just to see how it goes. All right? So let's make ourselves a plan on how to solve by factor. Okay? So here we go. Step number 1 says that we have to we can't do anything without our equation being equal to 0. That's why it's step number 1. We have got to get it equal to 0. No negotiations on that one. Okay? I mean, if you want to do things wrong, don't do it that way. But you have to do it that way in order to do things right. Okay? And can't get around it. Because it brings in the 0 product property into play. Which is why we do things that way. So I'm going to add 36x. Now, I don't care which side you make equal to 0, but one of the sides has to be equal 0 right from the start. Okay? So that gives me 4x to the 5th minus 40x cubed plus 36x equals 0. Now, preview of things to come. In the end, how many answers do we need? We gotta have 5 of them, right? Okay, we gotta get 5 answers for this one. Okay. Step number 2 says we need to factor completely. We gotta factor until we can't factor anymore. Right?
Yeah.
So what do you want to do first?
Split down the middle.
Nope.
Just find the.
Why do you guys find that so funny?
You were pretty confident in it. 4?
4x.
4x? We agree there's a 4x that we can take out?
Yes.
Okay. If I take out a 4x, what's left over? Let's do. X to the 4th power minus 10x. 10x what? Squared?
Plus 36.
Plus 9.
Plus 9. Okay. Can we factor any more?
Probably.
Well, look at this now, right? 2 numbers that multiply together to be positive 9 and add to be negative 10.
No.
You sure?
Probably.
Oh, wait.
Thank you.
Negative 9.
Negative 9 and negative 1.
Big break. Just leave it.
It's not.
Can we use our notes?
On the homework, sure.
I'm 10.
No!
Uh,
Oh, I know, I'm so mean. Oh, making you learn something. Can we factor any more?
Probably.
Yeah, we're gonna have to do it 5 times, so we have 5 answers now.
Can we factor any more, Paige? Why? Perfect squares minus perfect squares, right? 2 green ones, yes? Yeah.
Yeah.
Okay. So this one becomes what? Purple one.
That's a good question.
X plus 3 and
X minus.
x minus 3.
And then you can do it for the other side.
This one becomes what?
X minus 4.
You're a god.
Right? Can we factor any more?
Probably.
No, right? Because now they're all linear terms. Okay? So we factored completely. Now, what we're going to do is step number 3. Set each factor
Zero.
equal to 0 and solve.
Oh, is that why we have 5? Like.
So we set each individual one equal to 0. So 4x equals 0. X plus 3 equals 0. X minus 3 equals 0. X minus 1 equals 0. And x plus 1 equals 0.
Because we're finding our zeros.
Yep.
I get that. Yeah.
Wow.
Okay. And then we got to solve them. So we got x equals 0. X equals negative 3. X equals positive 3. X equals 1. And x equals negative 1. Yes, ma'am.
Can you explain the green? The green, like on the top. Like the 4x.
2 numbers that multiply together to be positive 9
Yeah.
and add to be negative 10 are negative 1 and negative 9.
But where is Oh, the x squared and the x squared equals x4, and then -9 and -1 is
9, and then they add to be 10. Because when you do the outers and the inners, -9x squared minus 1x squared is -10x squared.
Now let me make sure now. Right off that.
Okay? So those are the 5 answers that we need. 0, 3, -3, 1, and -1.
Get that, Taylor? Yeah.
Right.
I'm sorry. So basically,
Come on now. There we go. Step number 1. I'm not going to say anything. You guys tell me what to do.
make it
Set equal to 0.
Set equal 0, so how do we want to get it equal to 0?
Add 3x squared.
Okay?
Beat you to it. Yeah, it definitely was.
What do you mean they're not in the right
They are
order?
the order.
I thought that, never mind.
We want it in standard form, right?
So you put the 3x squared in front of the,
No.
In front of the 10. Okay? Next.
There goes factor.
Okay? Greatest common factor. We'll go down our list. First one is greatest common factor.
1.
1. That's not going to help us then, right? Okay? Next one is difference of perfect squares. No, because it's a trinomial, right? Next one is trinomials.
yes.
Okay? So,
Oh. Oh, the 2 cheeks. Okay,
first part of each of the parentheses.
question. X squared.
X squared, right? Because we need to get an x to the 4th.
No, so the first part of each parenthesis.
First part of each parenthesis. Okay? Two numbers that multiply together to be -10 and add to be +3. Do we agree?
Yep.
Okay. Matter which one is which? No? Okay.
We gotta keep going, you know?
Can we keep going?
We have to.
Okay, but can we?
We have to.
The first one.
Right? First one's not a difference of perfect squares, right? And it's not a different, or it's not a sum of cubes.
But we need 4 solutions.
I know.
Well, that's
Okay.
interesting.
Second one, not a difference of perfect squares, not a difference of perfect cubes. Okay? So we're done then, right?
So if we set equal to those, we'll get.
So now we can set those equal to 0.
What? How did you 4 solutions though?
Oh, just you wait, man. Magic's gonna happen here. Right?
I hope so.
Okay? Left one first. I want to solve for x.
Ah, because the square is going to be 2x.
Subtract 5, okay? X squared equals -5.
So yeah, divide by x.
Tap the brakes.
You got a square.
Got a square root, right?
Root it.
Okay?
Yeah.
So then it's going to be like x
Oh,
equals plus or minus the square root of -5, right?
Oh, yeah.
Yeah. Can we have the square root of a negative number?
No, we can't.
No.
No, we can't, right?
It doesn't work in
So those are imaginary, right? Right? What did our answer want?
Real.
Only real. So those two solutions don't work because we only wanted the real ones. They're still solutions,
But real.
but we don't want them yet.
So,
Okay? So now that's two of my 4 right there. Okay? Now let's go to the next one. Plus 2.
X equals a square.
that works.
Just the square root of 2
plus minus the square root.
plus minus the square root of 2. So that's 2 solutions, right? So now how many total solutions do we have? 4. We got the 4 solutions that we want.
So they don't all need to be zero?
No, we only wanted to find the real ones. So what's my final answer then, right now?
Plus minus square root of 2.
Plus minus the square root of 2.
Oh, that makes sense. You still have to find like the 4 solutions, but
But we're only, these directions said we only want the real one.
okay then.
Okay?
Not again.
Not again. You can so handle it. So handle it. Go for it.
Will they always be already in standard form or?
Not necessarily. If you look at, if you look at your homework tonight, 1 through 4, I think, are in standard form, but then after that, the 5 through 8 are not.
Okay. So
So what do you do?
Yeah.
Okay? So, gotta start by factoring it, right? Because it's already equal to 0.
oh wow, this is great. This is great news.
Figured it out.
Wait, so would it be a negative 5? Square root? Like square root of negative 5? Or-
Agree with the factoring of that one.
Yes.
Can't factor anymore.
No. Not
No. Okay. All right. So then that would become x plus 3 equals 0 and x squared plus 5 equals 0.
So the only real solution is x minus 3. Yeah, x equals negative. Wow.
So our only real solution, because we only wanted real ones, would be negative 3. I still got my 3 answers, right? My 3 solutions, my 3 roots, my 3 zeros,
Just 2 are imaginary.
but 2 are imaginary, because imaginaries always come in pairs.
I like this.
Huh?
Wow.